Recording in progress.
Okay, so for these problems here, these are pretty simple. Negative 18 minus 5i, 5 minus I root 6.
And that's the final answer.
Yeah. And then for this one, what you want to do is you want to simplify as much as you can. Because you're asked to write an a plus bi form, you really want to be very rigid about it. Like, okay, here's a and here's b. So I wouldn't leave it just like this for part b. I would actually do 2 over 2 plus or minus 4i over 2. And then continue breaking it down like this. And now you have it truly simplified. That's what I would suggest you guys do when you write in standard form for a complex number. So a plus bi is a standard form for a complex number. Just make sure the a and b are easily identifiable. So that's number 70. For 71, I cubed is I squared times I, right? Because if you do I squared times I, that gets you I cubed. That's negative 1 times I or negative I. So yeah, for I4 can be thought of as like this. Negative 1 times negative 1, which is positive 1, okay? So yeah, that's what's happening with 71. For 72, just plug in negative 3 or I or negative 3 plus I. So those answers, let me split the answers again, are right here. So again, for 70, those are the three answers. For 71, you have negative I or 1 for I3 or I4. For 72, those are the answers, negative 21, negative 10 plus 7i, and negative 22 plus I for 72. Oh, hold on. For part C of 72, just to show you really what's happening, you're doing negative 3 plus I squared plus 7 times negative 3 plus I minus 9. So you get 9 minus 6i plus I squared minus 21 plus 7i minus 9. If you clean it up, those cancel. I squared is negative 1 and positive I, negative 22 plus I. Does that make sense? Okay. So that's how you would work out 72 part C. And let's go through this a little more quickly. 73. 73, you could actually use a graphing calculator for that. There's a way you could do that. Or you could plug in 5 plus 2i straight up in the x and just make sure the left side equals the right side. But there is a way the graphing calculator can do it. Let me show you how. Hold on, it's being stupid. All right, why are you doing that? Let's see here.
It does not cross it.
Yeah, that's fine. Here we go. That's what I had to do. Yeah, so if you did parentheses negative 5 plus 2i, I is second decimal point squared, and then plus, or was it plus or minus? I don't remember. Minus, my bad. Minus 10 negative 5 plus 2i. I made a mistake somewhere. What did I do wrong? It was 5 plus 2i. Let's repeat that. Thank you. My apologies. 5 plus 2i. Yeah. So you could check the answer that way too. Second decimal point is where you do the imaginary number. You won't have that option on the test though, because we're not allowing graphic calculators, but just so you know, on SAT, ACT, you have that option. If you're a junior or sophomore, take it next year. For 74, change 16 to 2 to the 4 power, 8 to 2 cubed. Work it out using properties of exponents. You should be able to solve for it just fine. I think it was negative 8 for that one. For 75, they are equivalent. If you were to FOIL each of those, they'd be the same thing, because who cares if you reverse the x minus 5 to 5 minus x? You're squaring a negative, it comes out as positive anyway. For 76, that's going to be 7i, I root 2, negative 16 because you 16i squared. And that'll be 27i cubed, which would be negative 27i. Because I squared is negative 1, right? For 77, and yeah, parts A and B, you know how to find inverses. 70, I know you guys could solve that stuff. I'll just show you the answers really quickly and we'll move on. Yeah, so those are the answers right there. Hopefully we're okay with all that. So any questions? No? Cool. Let's move on. Great. All right, so the notes. Notes don't take too long today. See, we get at what time? At 11:35, I think. Yeah. So I'll make sure we're done in the next 25 to 30 minutes. Hopefully not that long. So you guys have enough time for the quiz. Quiz is short. All right. Yeah. All right. So we asked to find the guys, quiet, please. We asked to find the roots. You want to set y equal to 0, right? So to do that, your goal is to solve for x, right? So I'll move the 9 over to this side. And then I'll square root both sides. Actually, I'll do as another step.
Would you make that an I?
I will in a sec. So that becomes plus or minus.
Square and go away.
It does. It becomes x plus 5. Exactly. Exactly. That's the whole point. And you get -5 plus or minus 3i. So that's one way to do it. Whenever you have a binomial squared, like x plus 5 is a binomial and that's squared, I would prefer to actually isolate that binomial squared and then square root afterwards to make your life much easier. There's another way to do it too, which I'll show you in a sec.
Plus or minus. Oh, you square root it.
Right, square root. Go ahead.
So like that, how we did -5, but 5 should go in front of the plus or minus 3i.
Correct.
So if we did
Right.
plus or minus 3i minus 10.
That's fine, but usually I like to write -5 first. It's fine. Yeah. There's no harm in doing that, but usually you want to write the real number first and the imaginary number second. Now here's an alternative path. If you so desire, you could do it this way. Here's an alternative path. You could expand it, right? And factor, well, no, yes, exactly. We fooled. You're 100% correct. Right. Well, then you have to do quad form after that. Right. Then you get -10. You don't have to write this down, by the way. When I'm doing in black, you do not have to write down. But I'm just trying to show you why this is probably not the most efficient way. Because then you have to multiply some pretty big numbers. I mean, you will have a calculator at least you can use, like a 4-function calculator, but I don't know if I'd recommend doing it this way.
So doing it, so now that we have I.
Grace, go, you have a question. Grace, you have a question? Go ahead.
So if you're waiting for imaginary number, why do you do plus or minus? Because isn't I technically it's just -1?
No, you're square rooting. Whenever you solve by square rooting, like for example, like when you have x squared equals 4, and you solve by square rooting, what does x equal? 2 or exactly. That's why you're doing the plus minus. It's always when you're square rooting. No, but the 9. We square root 9, that's positive. Plus root 9 plus
Oh,
minus
so
3.
but the negative like disconnect.
Exactly. Yes. No, I just there. Right. Right. Exactly. But if you keep going here, you can see why this is not probably the best technique when you quad form it, because it's actually more work this way, I feel. So you get 5 plus minus 3i. Yeah, that's not good. I mean, it's good. You get the answer. So I meant to say -5, but it's just more work that way. So I prefer if you can just isolate the binomial squared and square roots. That'd probably be more advantageous, in my opinion. Let's try another one here. Let's look at part B. Now, part B, you could quad form it also, but let's do completing the square. You guys remember completing the square? This is yet another technique. Let's kind of bring it back to some old stuff here. How do I complete the square? Do you guys remember? Yeah, you take half of -4 and square it, right? To do half, which is gonna be 4. Completing the square, right? So I'm just showing you another technique. So you get x minus 2 squared. Then you square root.
Yeah. Why is it I do that?
Because you have,
Plus minus I.
whenever you square it, you always put plus minus. Exactly, right. 100%. Right.
Why is it plus or minus the square root of 6? So there.
Okay, well, but root 5, I don't know what root 5 is as a number, right?
Like, if
Okay.
you have it, oh, it's the plus or minus.
You're overcomplicated, guys. You're 100% overcomplicated. What x squared equals 6? What does x equal, guys? Plus or minus root 6?
It should be.
Because x is.
That makes.
Okay, x is 2. Okay, what if I put a negative here? Okay,
I would say plus.
I guess it's supposed to be.
okay, what if I have this, guys?
Is it?
It's plus or minus.
Okay, so if you have this, that's gonna be x squared equals 6i squared, right? Right, because isn't I squared negative 1? Okay, when I square root, what happens? Plus or minus I root 6. Because if I put in I root 6 in here or negative I root 6, I still get the same thing.
Let's say X.
Whenever you square everything by solving, always have to put plus minus, 100% of the time, always put plus minus. You have to, because if you put it back in, because both answers work, that's why. It gives you the whole story. If I put I root 5 back into the equation, okay, here, I'll prove it to you right now. Here, let's do this. Okay, really quickly, guys. I'll undo my, let me punch this equation to y equals. Here, x squared.
Why'd you plus 4 plus or minus 3i equals that?
Give me a sec. I'll get there in a sec. All right, if I do alpha trace and type in, what was the answer? I root 5, right? I root 5. I should get 0, right? Ah, geez. Why did I not like that? That's weird. Okay, let me do this. It's bugging out. Here. I root 5 squared minus 4 I don't worry about the wait, why is it wait, what was the answer for that one again? I mean, did I have the right answer? It was, oh, it's 2 plus or minus. Yikes, sorry. Ken, you had the wrong answer. Sorry about that, guys. Let me fix this more time. Okay. Geesh. Here, it's 2 plus or minus. Okay, insert 2 plus. Insert 2 plus. I get 0. If I change it to a minus, you still get the same thing. You still get the same thing. That's why we have to do it. Whenever you solve by square root, you always put plus or minus, because we throw it back into the equation, you get the same response. So even as a radical, who cares, or an I, it's still the same thing. Okay.
How'd you add the plus 4?
Plus 4?
Yeah.
Oh, that's completing the square. That was down here. So you take half of negative 4 and square it. That's called completing the square process. So what it enables me to do is to factor this like this, and I square it afterwards.
Can you not just factor it like that?
You can't factor this, it's not factorable, this right here. You can do plus 1.
Minus 9 and then factor x squared minus 4x.
Yeah, but you have to have 0 on the other side to do it correctly. If you want it factored. I mean,
You take half of 4 and square it.
I know what you're saying, Elliot. You're saying this. I get what you're saying. You're saying move the 9 over
Minus 9.
and factor out the x, right? Okay, but then what do you do after that?
No, I said x minus 4 squared. Because that would make it x squared and.
So you can do x, okay, x squared minus 4x. But then what are you gonna do after that?
Oh yeah, I let you mess it up.
Yeah, totally. Okay, good. All right. All right, moving on. And what were the answers again? They were Yeah, -5 plus minus 3 root I. So let me snatch that. Let me snatch the other one. And let me get rid of everything else. Okay, so for number 80, these are our two answers, right? What do we notice here? We notice that they're almost identical because it's really like saying this, -5 plus 3i and -5 minus 3i. And that's like saying 2 plus I root 5 and 2 minus I root 5. So what do you notice? They're almost identical, but the middle operation is different. That's what we notice. So we're going to talk about these patterns in the next problem. So whenever you solve a quadratic equation that has imaginary solutions, they can be paired up in this way. A plus BI and A minus BI. A plus BI and A minus BI. We're going to talk about that in just a little bit. So let's move on to 81. So when you add these two, right? What do you notice is happening when you add these two? What cancels? Well, I'm sorry, what was that? Perfect. What are you stuck with? 2 plus 2, which is 4, right? Let's multiply them out. But multiply them out, what happens? So in this case, you have to FOIL. 2 times 2 is 4. Minus 2i plus 2i minus I squared. You get 5. So that's what we're going to do in each case here. Notice every time we get a real number. So if I do the next one, I should get 6, I think. -8.
Is that an I on the end this week?
For where?
Is it 4 minus 2i plus 2i minus?
I squared. And then you have 4 minus -1 because I squared is -1. And then 4 minus -1 is 4 plus 1, which is 5. So you get 5 over here. So if I do this, let me do this one more time for this one here. If you FOIL it, right? What's 3 times 3? 9. What's 3 times 5i? 15i. -5i times 3 is -15i. And -25i squared. Those cancel. 9 plus 25 is 34. And just to save time, this will be 16 minus -1, which is 17. This will be 1 minus -3, which is 4. If you FOIL these for C and D, you'll notice the outer and inner terms will cancel. So what's going to happen here is when you FOIL, actually, I'll talk about it on the next page. I squared is -1, guys. We're okay? Okay, let's move on. So let's look at this a little more deeply in parts E, F, and G. So what would you multiply 3 plus 2i to get a real number? You'd multiply this by 3 minus 2i. And that's because when you FOIL them, the outer and inner terms. Yeah, I know, it's lunchtime. Cancel each other out. It's better than the days when lunch is like 12:45 or something like that. So yeah, when you FOIL them, the outer and inner terms cancel each other out. Okay. With part F, if I work out part F, they're not going to cancel out, right? Because if I FOIL, I get 16. They get negative 12i, negative 20i, and plus 15i squared. 16 minus 32i. So yeah, they don't cancel out. But for part G, what are you going to multiply this by a minus bi? So what this leads to for parts E and G, they lead to this. They're called complex conjugates. A complex conjugate is when you have a complex number and its conjugate is very similar to it. So the only difference is you change the positive to a negative or vice versa. So those are called complex conjugates of each other. And those solutions always come together whenever you solve a quadratic equation that has imaginary solutions. They always pair up. Like look at, for example, parts B and C of 86. Those are conjugates of each other, right? So we expect that to happen when you get an imaginary solution. Imaginary solutions always come in pairs. So that's kind of the key takeaway here. Outer and inner terms. It's an ampersand.
Why would I not be D?
Those are called conjugates, but not complex because they don't have imaginary numbers. But similar, right? They're similar, right? Because when you have radical answers, same thing. A lot of it comes from quad form too, right? Because quad form has that plus or minus that radical part. That's where it really comes from too. All right, let's keep moving. So for these problems here, how do I handle this? So you're asked to find a quadratic equation that satisfies each of these solutions. Here's what I'm going to do. We're going to work backwards.
So 5i times 3i is that, I didn't get to write it down in the.
Oh, this is for part F?
Yeah.
It was 1 minus 32i. When you work it out, you get 1 minus 32i. Yep, no problem. Okay, we're going to work backwards here. So before I do 886, let me just show you what you guys used to do back in the day. Like back in the day, like if I gave you an equation, right? Don't write this down, but just pay attention. So like if I have this, right? How would you solve it? You would factor, right? You know that factor x plus 1, x plus 4. And x plus 1 equals 0. X plus 4 equals 0. What does x equal? Negative 4, negative 4, right? Okay. But what if I gave you this, right? What if I give you the answers? Now, if I work backwards, I know that I have to add 1 to both sides. Or add 4 to both sides, right? And then I'd have to do this, right? Then I have to FOIL. And I do this. There we go. And what's that? This is how we're going to approach each problem in 86. We're going to work backwards. So what I'm going to do for part A is I'm going to start by doing this. So if you look at x equals -5, where did that come from in the first place? X plus 5 equals 0, exactly. Where did x equals 3/4 come from? From 4x equals 3. And then 4x minus 3. Yeah, thank you, Luke. You got it. Does that make sense what I'm doing so far? How I'm working backwards? I'm taking the solutions and I'm reversing the process, right? I'm getting back to the original equation. So instead of taking the equation, instead of going top down, I'm going down up. That's what I'm doing here. I'm going in reverse direction. This is actually, a lot of teachers don't teach it this way, or tutors or whatnot. So might be a little confusing to show this to someone else, but I feel this is more efficient doing it this way. And I'll show you why, once I finish all these problems, why this is more efficient. Then I do this, right? Then I do this. And then finally I do this. Okay. So you can see how I'm able to get the answer by working backwards. Okay. That's 886 part A. So I'm going to do the same thing for part B. I'll do it off to the side here. So x equals plus minus 3i. So again, you can consolidate this, right? Because 3i negative 3i is plus minus 3i. So now I'm going to do is I'm going to square both sides. Well, obviously square plus minus 3i. What do you get? Negative 9. You see how I got negative 9? Okay, what's 3 squared, guys? What's I squared? Boom, negative 9. And who cares about the plus or minus? We square a positive, it's still positive, right? You square a negative, it's still positive, right? It doesn't matter. If you square plus or minus 3, it's still 9. But how much you square the I? It's negative 1. Right? Because 3 squared is 9, but I squared is negative 1. Plus or minus doesn't matter because you're squaring it. And then when you bring it the 9 back, now you have the equation. So this is the equation it came from. It came from that. So I'm going bottom up. If you want to start by putting this as a top step and work from a top down approach, that's fine. But I'm just showing you that this is just a reverse of solving an equation or quadratic equation. We're doing the reverse of it. Let's try it again for C. X equals 5 plus minus 2i. If I reverse the process, what should be my next? What should be the step right above it? Minus 5. Then I got to square both sides, right? Could be a question. Go ahead.
What's like the real life application of
None. So, none. Just abstract math. Just want to torch you guys. I don't know. Negative 4. And you have x squared. So what I'm doing is going in reverse, right? Again. Move the 5 over. Square both sides. Foil it. And that's negative 4. Because you can square in 2 and square I, it's negative 4. And then move the negative 4 from right to left and get that. And then for D, switch colors to the contrast. X equals negative 3 plus minus root 2. X plus 3 Okay, what's the square of root 2, guys? Yeah, even if it's positive or negative, doesn't matter. X squared plus 6x plus 7 equals 0. So again, I'm taking a bottom-up approach for doing these problems. Because you know what the final answer is, but what equation did it come from, right? And again, in the past, you've been given equations and solved it from a top-down approach, We're just reversing it. Does that make sense what I just did? And again, it's all recorded, so you can watch the step-by-step process. Now, don't write this down. Here's what some people will do. If you talk to maybe an upperclassman who's taking this class or a tutor or another teacher, they might say, well, you should do this. X minus each number, right? So it's X minus 5 minus 2i. X minus 5 plus 2i. And then they FOIL. Well, not FOIL, but they distribute. But you generate actually 9 terms, which is kind of crazy. I'm doing it fast in the interest of time, but I mean, you'd have to kind of slow it down a little bit to make sure you don't make a mistake. Oh boy. Right? See how crazy that looks? These cancel. That's actually negative 10i. Sorry, that those cancel. You have x squared minus 10x plus 29. But it's just a lot of work to do it that way. So I would suggest trying it my way. That might be more efficient. Luca, go ahead.
What was the answer?
D was x squared plus 6x plus 7 equals 0. Yeah, plus 7. Because you had x squared plus 6x plus 9 equal 2. Then we did 2 over. You had 2 on the right side, right? Yeah. And x squared plus 6x plus 9 on the left side. Okay, good. All right, discriminant and complex conjugate. And then we should be done in a few minutes. And then we can do the quiz. So, yeah, what's the discriminant? Well, first of all, you should know quad form. And by the way, we'll give you quad form in the test. You don't have to have it memorized, even though you should know it. You should know it. But this part right here is called the discriminant. Now, this is an interesting play on words. When you hear the word discriminants, what does it sound like to you?
Discrimination.
What is discrimination? It could be anything, you know, just this, that's not math class anymore. Just tell me, when you hear discrimination, what do you think of?
Like,
Not giving equal opportunity.
Perfect. I love that. That's a great answer. Not giving equal opportunity. And why you're not giving equal opportunity? Because you're judging based upon differences. Is there sexual discrimination? Sure. Is there gender discrimination? Sure. The same thing. I'll back it a little bit. Yes, there's all those things. Is there age discrimination? Is there racial discrimination? Is there socioeconomic discrimination? Absolutely. What would be sexual discrimination? Like, okay, like, well, maybe you give someone a job because they're a man and not a woman, vice versa, right? Or what if like age discrimination, like someone's 60 years old, you don't hire them because they're too old, you hire a 30-year-old. Or socioeconomic, like, well, maybe a college doesn't accept this person because they can't pay full tuition. Or racial discrimination, we talked about that often in 2020, we had racial reckoning, right? So it's a judge based upon differences. In math, which is not as controversial, it's kind of the same thing. The discriminant is judging what kind of solutions you'll have, right? Based upon the differences that it equals, right? If it's equal to 0, greater than 0, less than 0, it's going to judge based upon the differences in its answer. So discriminant, it's kind of the same thing. It basically judges based on different solutions. So it helps determine. It's like a determinant in a way. In fact, actually, if I look up the word discriminant, which I did earlier today. Yeah, it says here, an agent or character that enables things, people, or class to be distinguished from one another. It helps distinguish the types of solutions. It's probably a better way of putting it. So when this happens, when b squared minus 4ac equals 0, the discriminant goes away. That means you're going to have one real solution. If it's greater than 0, that means you're square rooting a positive number. You got yourself 2 real solutions. That should not be a plural. Here, when it's less than 0, you have 2 imaginary solutions. Or in essence, you have 1 x-intercept two x-intercepts. And here you have no. X-intercept. Okay. So that's what that means from a graphical standpoint as well. Because if the inside's negative, you're rooting a negative number, that's going to be imaginary, right? And it's not going to cross the x-axis because the coordinate plane assumes real numbers. Okay, we're good? All right, so we'll wrap this up really quickly here. We'll do the quiz. So when you cross twice, you have two real roots. Here you have three. But when you shift this up, here you have none. And here you have one. So,
You have to cross the x-axis.
right. X-intercepts.
Wait, so if it's above the x-axis, does that mean it's equal to 0?
No, it means the discriminant will be negative. Here, b squared minus 4ac was less than 0. Here, b squared minus 4ac.
Is this like something we'll have to do on a test? Or
Something like that, yeah. That's when that would sit on the x-axis. Like that. But right. But B and D are not quadratic, so you don't use a discriminant for B and D because B and D are cubic. So the discriminant is not applicable towards B and D, but it's applicable towards A and C because those are quadratic. So discriminant's only for quadratic functions. But still, if you cross the x-axis 3 times, you have 3 real roots. If you cross it once, you have 1 real root, or twice 2, never cross none. So, and recall that a polynomial function with a degree n should cross the x-axis at most n times, or can cross at most n times. So here they're asking you to make sketches of all 3 possibilities where it touches once, twice, or 3 times. So what if you touch once? You have a 3rd degree. If it touches once, it probably look like this.
Are there many possibilities for it to look, or is that like the only way in the market that would have to?
I mean, we could flip it over, I guess. I mean, but see how like yeah, see how like once, twice, 3 times. So anyway. Okay, hope that makes sense there. And then can a 3rd degree equation have 0 real roots? The answer is no. That's because imaginary roots come in pairs. Assuming, and they kind of messed up this question. Assuming that the coefficients are real numbers. You will get when you move into the pre-calculus, you'll see some situations where the coefficients may not be real. We're not going to talk about that in this class, but they have to come in pairs if you have all real coefficients. So yeah. Okay, all's good. That too. Yep, that too. Right. Okay, homework's here. Extra practice if you want it. Perfect timing because this is what the last class had, about 10. So you have a little more time than the other class. So let me stop the recording.